Hello everyone. In this video, we'll talk about Maven and what is Maven and why do we even use it in the first place. So let's say we have a Java project and I want to connect to a MySQL database, right? So in that case, I'll need a library or a dependency to use in my project. So how can I get this library? So the first thing we need to do, and if we don't want to use Maven, we can just download the jar from the internet. For example, we can look for it online, and then we can manually add the dependency to our project. So in IntelliJ, for example, we can go to project structure and add a jar. I already downloaded a jar, so I have it right here, the MySQL connector, and that's pretty much it. Apply, okay. So if we go here to external libraries, we can see it right here. There we go. So we have the MySQL jar in my project, and then I can use it in my project normal. So this is how we do things if we don't want to use Maven. But this approach is obviously not really good, and it causes a lot of problems. So let's see these issues. So if we don't use Maven, so the first issue is we need to manually add the dependencies, right? So let's say I have not just one dependency, but I have a bunch of dependencies. So each time I'll have to add the dependency, I need to look for it online and download it and then add it manually to the project, which is not really efficient. The second thing is if you want to change the version, right? So if I want to change this version of MySQL from 8032 to 182, for example, how can I do that? The way we can do it is we delete this jar and we download the new jar. And as I said earlier, it's not really efficient and it's slow. And the bigger issue of all this is how can we work in a team with this approach? So if I'm working in a team of 5, for example, and I add this library or this dependency, how can the other in my team know that I added? So if I push the code, for example, and I use this library in my code, they will get an error because they don't have this jar in their project. So I need to send them a message and tell them, please download this jar and do the same thing every single day whenever I add a new dependency. It's gonna be a mess. If you work in a team and you are manually adding jar to your project, it's gonna be a real mess. And another thing is how we can run the project in a production environment or in a test environment. So let's say I want to deploy this app. So how can I deploy it, for example, in a production environment? So I need to go to that environment. I don't have a build tool to take care of downloading the dependencies. I need to do it manually. I need to compile the project. I need to do all these things manually. And it's gonna be a nightmare. It's gonna be a really nightmare to compile the project and add the dependencies manually. And it's just gonna be hard and it's gonna complicate the things. So we don't have something to automatically build the project, right? And compile it and run it. So this is why we're gonna use Maven. So let's see. So Maven basically is a build tool, right? And by build tool, I mean it helps us download the dependencies that we need and also compile the project and package it. So as I said, it's a build tool. It can manage your project dependencies, so we don't need to manually add the dependencies to our project. Maven will do it for us automatically. And also it can compile your project by convention. And what I mean by convention is, so this is a Maven project. And a Maven project have a certain structure. So we have source, main, Java. And this is not done by it's done by purpose, right? Because Maven seeks this convention. So Maven looks for the files inside of this folder, this main Java folder. So here you need to have your Java classes inside this main Java folder, because when you run Maven, it goes in search for your Java files inside of this package. So this is why I said it compile your project through convention. So the second thing we need to see is the POM file, and this is the most important file in a Maven project. So let's see it. So a POM file is basically a description of your project, right? Let me delete this right away. So in a POM XML, we have information about the project, for example, the artifact, the group ID, which is just names, for example, names of your project. We have the version. We have also certain properties like which version of Java we want to use. I'm using Java 11 in this case. And here we have the dependencies. So in case we want to add dependencies, we can do it this uh, through this tag dependencies. For example, if I want to add the the MySQL dependency, I can just add like this. There we go. We can just add this tag dependency MySQL, and that's it. That's pretty much it. So I can delete this jar. We don't need it anymore. Don't want to add it manually. Okay, I'll delete it later. But anyway, this is how we add dependencies. We can just add this tag. And if you want to, you get this, you can go to Maven repository. This is where you find all the dependencies, right? So, for example, I'll search for, uh, I'm not gonna allow you to use ads. I'll look for MySQL. There we go. So we have the MySQL connector. Oh my God. Okay, there we go. And I can just copy this. So you copy this and you paste it on your project. And this is how you get the dependencies. You get them from the Maven repository. Okay, now let's go back to our slides, and here we're gonna see the most important part of Maven, which is lifecycle. So Maven gave us a bunch of lifecycle commands that we can use to run our project. So 1 second, we can go to terminal. Right. So all these are commands that we can execute with Maven. So the first one we'll see is validate. It's basically validate the project is correct and all necessary information is available. So we can run it, for example. The way you run Maven command is by using MVN and you write the command validate. Validate. And as I said, this Maven validate just simply validate the project. You see, is the structure of a project correct? And all the files are correct. And obviously we have a correct Maven project because, as I said, we have the convention of Maven and it's built successful. The second one is Maven compile. This is compile the source code of the project. So as I said, we have all our Java classes inside of this Java main Java folder. So when I run Maven compile, it will compile it for us. It will compile the project for us. And as we can see, we have this new folder here, target and classes. There we go. So right here we have the compiled version of our main class. This is by the way bytecode. It just decompiled. This is a main.class. So it's a bytecode and it's compiled for us automatically, but by Maven. We don't have to manually go and compile the project. Maven do it for us automatically. We have also command like test. We run tests. We have package, and this one take the compiled code and package it in a distribute format such as jar. This is obviously a very important command. If I run Maven package, it will create a jar file. For example, if I want to deploy my application, I need a jar. So it will be, there we go. We have it right here, the jar file. We have Maven verify to run any checks to verify the package is valid. And we have Maven install to install the package into local repository for using a dependency in other project locally. And finally, we have Maven deploy done in an integration or release environment, copies the final package to the remote repository for sharing with other developers in the project. Usually we use Maven install, and the cool thing about Maven is when we run Maven install, for example, it automatically runs all the commands before it, right? So let's say I run Maven install, it automatically runs Maven validate, Maven compile, Maven test, Maven package, Maven verify, right? If I run, for example, Maven test, it runs Maven validate, Maven compile. If I run Maven package, it runs automatically Maven validate, Maven compile, Maven test. And there we go. So this is the cool thing about Maven. We don't have to manually write all of these commands. It's smart enough to know how to do it. And another method is very useful is clean and remove all files generated by the previous build. So if I want to delete this target folder, because for example, I changed the code and I want to have a new classes, you can run uh, Maven clean, and all of this will be deleted. There we go, it disappeared. And as I said, and a useful command that we use a lot is mm, Maven clean install. So this command deletes the target, and we run Maven install that will compile and package our application. We can use the two commands in the same line. There we go. So this is how this lifecycle method works. And we can see right here that we have the target with the compiled classes in the package. We have here in external libraries, we can see that we have this Maven connector, right? This is Maven connector imported by the Maven from the Maven repository, right? And let's say, for example, I don't know, I want to change this version. I no longer want to use this version of Maven. I want to use this version. Oh my God. I'm just gonna copy this, right? And there we go. So here I changed the version from 3.2 to 3.1. And right here we need to click this, we need to load Maven changes. And what does this load Maven changes? It's simply search for this version from the repo, from the remote repo, and bring it to our local project. So if I go, there we go. So if I see here, the version changed from 3.2 to 3.1. And this is simply just by modifying this POM XML. This is why Maven is so powerful. Just from this POM file, we can do a lot of cool things from our project. And now when I share my project with others, they can just have this POM file and they can use the commands that we talked about earlier, these lifecycle commands to run the project on them locally. Or if I want to, for example, deploy my, I want to build my project, I can just use this package and I can have the packaged version and deploy it in an environment easily using Maven. So this is pretty much for Maven, and that's it.